Okay, we have to express this as a single fraction with a rational denominator. So first thing we have to do is we have to look at these two denominators, and you'll notice you can get a common denominator of 6 minus 3. Okay, difference of two squares, root 6 squared minus root 3 squared. So 6 minus 3 is going to give you 3, and then you can just cross multiply, so that denominator times that numerator, root 6 plus root 3 times 3 root 2 plus 4, and then those two multiply together, root 2 minus 1, and root 6 minus root 3. And don't forget to add the third term on the end. Okay, now let's expand carefully. Root 6 times 3 root 2 is 3 root 12. Root 6 times 4 is 4 root 6. Root 3 times 3 root 2 is 3 root 6. And root 3 times 4 is 4 root 3. Let's keep going. Root 2 times root 6 is root 12. Root 2 times minus root 3 is minus root 6. Minus 1 times root 6, minus root 6. And minus 1 times minus 3 is plus root 3. All over 3. Minus the 2 on root 6 minus 1. Okay. Let's clean this up further. Now we've got 3 root 12 plus root 12 is 4 root 12. 4 root 6 plus 3 root 6 is 7 root 6. Minus root 6 minus root 6 is plus 5 root 6. And then we have 4 root 3 plus root 3 is 5 root 3. All over 3. Now, before I take away this term here, I'll put take away, but just take this term here and let's rationalise the denominator because it will make things a lot easier. Okay, so just multiply by the conjugate, top and bottom. And when you do that, you're going to get 2 root 6 plus 2, okay? And on the bottom you're going to get 6 minus 1, and get a difference of two squares, which is 5. So 2 root 6 plus 2 over 5. All right? All right, that's not too bad. Now, this here, all right, root 12 is 2 root 3. So 2 root 3 times 4 is 8 root 3. Right, now 8 root 3 plus 5 root 3 is 13 root 3. And we've still got the 5 root 6. And the 3 minus 2 root 6 plus 2 all over 5. Okay, it's not too bad. Okay, so now 5 times 3, 3 times 5 is 15. And then 5 into 15 goes... 3 into 15 goes 5 times, so we're going to say 5 times all of that. And then minus 5 into 15 goes 3 times, so 3 times all of that. 3 times 2, root 6 plus 2. Okay, all right, now 5 times 13 is 65. So that's root 3, 5 times 13 root 3, plus 25 root 6, minus 6 root 6, minus 6, all over 15. Okay, and then we just get 65 root 3, and then 25 root 6 minus 6 root 6 is plus 19 root 6, minus 6, all over 15. And that's as far as we can go. There's nothing else you can simplify there, so that ends that one. All right. Now the next question is 3L. 3L is this question here. We have to express this as a fraction, as a single fraction with a rational denominator once again. Okay? Now, what I would do in this case, have a look at the denominators. They don't multiply to give you anything nice like a difference of two squares. So what I would do with that one is I would rationalise this denominator and get this as a nice a single fraction with a rational denominator. And I'll do the same with this one, rationalise this denominator. So let's take each one. Take this one first. Multiply by the conjugate, okay, which is the denominator. Without the minus, you put a plus, right? Okay. And then root 5 times root 3 is root 15. Root 5 times root 2 is root 10. Minus root 2 times root 3 is minus root 6. And minus root 2 times root 2 is minus 2. All over 3 minus 2, because it's root 3 squared minus root 2 squared, which is 3 minus 2, which is going to become 1. All right? Now, none of this simplifies, so leave it where it is. Now, let's go to the next fraction, okay? And let's also rationalise the denominator on that by doing the same thing. So multiply by the conjugate and expand it out. 2 root 3 minus 2 plus root 3 times root 3 is 3, and root 3 times minus 1 is minus root 3. Okay, all over, again, difference of two squares, that's 3, root 3 squared is 3, minus 1 squared is 1, so it's 2. 3 minus 1 is 2. Okay, so now we have, just checking, yes, that's fine. Okay, so now we have this fraction here, root 15 plus root 10 minus root 6 minus 2 over 1 minus, remember it said minus that fraction there, so it's minus what we had here, 2 root 3. Oh, by the way, minus 2 plus 3 is 1. Is 1, so... Oh, and I didn't collect the like says there, did I? So 2 root 3 minus root 3 is root 3. And minus 2 plus 3 is plus 1. Okay, so that ends up being much nicer. All right, common denominator of 2. And then just cross multiply. So 2 root 15 plus 2 root 10 minus 2 root 6 minus 4. And then 1 times that will be minus root 3 minus 1. Okay, minus root 3 minus 1. And let's look for any like surds. Well, we can only see minus 4 minus 1. So it's 2 root 15 plus 2 root 10 minus 2 root 6 minus root 3 minus 5 all over 2. Okay, and that's L. There's nothing more you can simplify there. All right, now question 6b says if x is equal to root 3 plus 2, simplify x squared plus 1 on x squared. All right, so we're going to square that, put it there and there. All right, and then we have to simplify that. So just put it in brackets, root 3 plus 2 squared, which is that, plus 1 on root 3 plus 2 squared. Okay, there's that one. All right, let's keep going. Now, if you square this, it's a binomial expansion, all right? So root 3 squared is 3. And then 2 times root 3 is 2 root 3, double that, 4 root 3, and 2 squared is 4. Okay? And you're going to get 7 plus 4 root 3. So the same thing's going to happen on the bottom here. So just write 7 plus 4 root 3. On the next line, 7 plus 4 root 3 over 1 plus 1 over 7 plus 4 root 3. Okay? Take this and multiply by the conjugate, 7 minus 4 root 3. Just makes it easier. Okay, so you're going to end up with, it's over here, 7 plus 4 root 3 over 1, and then you've got 7 minus 4 root 3, because times 1 is that, and over here you've got 49. Okay, 7 sevens are 49, so difference of 2 squares. So 7 sevens are 49, all right, and then you have 4 fours are 16, 16 times root 3 times root 3, so 16 times 3 is 48. So you've got 1, that's equal to 1. So you're going to get 7 plus 4 root 3 over 1 plus 7 minus 4 root 3 over 1, which is simply going to become 7 plus 7 is 14, and 4 root 3 minus 4 root 3 is 0. It's all over 1, so 14 is your answer. That ended up being nice. Now, let's do C. Okay, C is done the same way. Just do a simple substitution. All right, here we go. So x is root 3 plus 2. We put that there. Root 3 plus 2 plus 1 over root 3 plus 2. Okay, so we multiply by the conjugate here. Oops, plus 2. So you multiply by root 3 minus 2. Root 3 minus 2. Okay, sorry, that's a 2. All right. And you still have this term, root 3 plus 2. Put it over 1. And this becomes, so plus, root 3 minus 2 times 1 is root 3 minus 2 over, the difference of 2 squares is 3 minus 4, right, which is minus 1. All right, so that's simply going to become root 3 plus 2 minus, bring the minus at the top, minus everything that you see there, right? So minus root 3 plus 2, all over 1, which you don't have to write anymore, and root 3 minus root 3 is 0, and 2 plus 2 is 4. That ended up being really nice as well. Okay, the next question was number 9. Number 9 says we have to simplify if 2 plus 1 over x is equal to root 3, where x is not equal to 0. And remember, they tell you that because, right, x can't equal 0, because if it was, you get an undefined answer here. So, find x as asserted with a rational denominator, all right? Now, you've got this equation here and you've got to find x. So this is how I would approach it. I would take away the 2 on this side, so I'd end up with 1 over x equals root 3 minus 2, okay? Now, that's over 1, okay? Turn both sides upside down so you get the x on the top here and the 1 on the top here. And then just rationalise the denominator, because it does say with a rational denominator. So you can't leave it like that. You have to multiply it by the conjugate. Okay, and then just multiply numerators together. 1 times that. 1 times root 3 plus 2 is root 3 plus 2. And then the difference of 2 squares here will be 3 minus 4, which is minus 1. So your answer is going to be minus root 3 minus 2. Okay, because the minus goes to the top. All right. Now, that's number 9. Number 10, we have to rationalise the denominator on this expression, which is not hard. Okay, you do exactly the same thing. It doesn't matter, you know, if there's a B or an A or an X or numbers there, you always do the same thing. Okay, don't be thrown off when you see a pronumeral instead of a number, because a pronumeral stands for a number. So you treat the expression the same way as if you would if there were numbers there, okay, under those third signs. So you simply have to rationalise. How would you rationalise the denominator? Like this. Well, you do what you've always done. Root b plus 2 over root b minus 2. We're going to multiply by the conjugate, which is root b plus 2, right? So you take the denominator and you've got a minus there, so you're going to make that a plus. All right, the top becomes root b plus 2 squared, and the bottom is a difference of 2 squares. Root b times root b is b, and 2 times 2 is 4, so it'd be b minus 4. Okay, expand the top, root b squared is b. 2 root b, double it, 4 root b. And then 2 times 2 is 4, And you've got b minus 4 on the bottom. And that's that. We need to remember that that whole thing was squared. We've only found what's in there. So let's square the 4. And now we'll get the right answer, which is 16.